Dear friends, welcome to PJ and PJ Solutions.
Dear students, in this video I am going to explain the solution of linear programming problem by simplex method. Now, a linear programming problem will be given like this format. Here is the question. Apply simplex method to solve the linear programming problem. Maximize z equal to 2x1 plus 3x2 subjected to the constraints x1 plus x2 less than or equal to 1 and 3x1 plus x2 less than or equal to 4. Non-negativity variable x1 comma x2 greater than or equal to 0. Now first we need to formulate this LPP. Now how to formulate the LPP? Now let us understand how to formulate the LPP first. Right. Now I'll explain the formulation of LPP. Here is the our problem as given in terms of maximization. If your problem is given in terms of the minimization, we have to convert that is into the maximization. In next video you can find out. Okay, that video link is available in the description box. You can go through that. Now I am discussing the maximization z and constraints also less than or equal to symbol only. In this problem I am going to explain the solution of linear programming problem by simplex method with the maximization function and the constraints having the less than or equal to symbols only. In the coming videos, I am going to explain with the mixed constraints, that means less than or equal to as well as greater than or equal to. In coming videos, you can watch. Right. First, let us formulate this one. Now, whenever the less than or equal to symbol is there, we need to add the slack variable. Less than or equal to means on the right hand side something is less than as comparing to the left hand side. This is something is less than, that is the reason we are going to add the slack variable. Slack means nothing is something is less on the right hand side. Okay. In this second equation also, which is less than or equal to, we have to add the slack variables here. Okay. Let us do the constraints. First, we concentrate on the constraints. Do the formula. Let us do the formulation now. See, x1 plus x2 plus s1, which is equal to 1. Right? Okay. Now again, 3x1 plus x2 plus s2, which is equal to 4. Now I use the s1 slack variable for the equation number 1 and s2 slack variable for the equation number 2. Just I am going to add it. This is 0 s2. Here also 0 s1 plus like this. Now we have to add the cost of the this slack variables in the objective function. Objective function is max z equal to 2x1 plus 3x2 plus 0 s1 plus 0 s2. Now we are going to take the cost of the slack variables in the objective function as zeros. Why? Because of this zeros, the objective function will not changes. Okay. Now here I formulated everything here. Now you can go through. You can see this is I typed here already. Now here we have to type this is 0 s1 and plus 0 s2 like this. This is the formulation of linear programming problem. Here, whatever I written here, the same thing I have typed here. Maximize z equal to 2x1 plus 3x2, 0 s1 plus 0 s2, subjected to the constraints x1 plus x2 plus s1 plus 0 s2 equal to 1. Now, 3x1 plus x2 plus 0 into s1 plus s2 equal to 4. Why we are adding these slack variables? In order to make a balance of the equation. Now on the right hand side something is less, so that we are going to adding the slack variable in order to balance the equation. Now that is the reason we added the slack variables. Yes, slack variables also greater than or equal to 0 only. Now like this we need to formulate the LPP. Right? Okay. Now this is the first step in the simplex method. In the simplex method, the steps. First, you have to look after your objective function, which is maximization or minimization. If it is the problem is given in terms of maximization, nothing to worry, and just go for the constraints, and which are constraints are less than or equal to, just you have to add the slack variable for each equation. Right? Okay, in order to balance the equation. Now we are ready to apply the simplex method now. Now here is the problem we are given. The formulation of LPP I written already here. Now this is the formulation of LPP. I copied and paste one more time here. this 0 S1 and plus 0 S2. This is the formulation of LPP. So after this, we need to construct a simplex table. This table is called simplex table. Here we can observe here, in the first column, basic variables you have to write down. The variable which is in this column, we are going to having the variable. This variable are going to be a solution of the problem at the end of the iteration. Okay. Now cost of the variable. Now cost of the variable means whatever the variables in the whatever the basic variables are there, what is the corresponding cost in the objective function? That cost we are going to write it down here. This is the value of BV. Value of BV means at the end of the table, the solution of these variables are going to be here. In the first iteration, on the right hand side values, right hand side column vector we are going to write down. Here the right hand side column vector is 1, 1 and 4. We are going to write down by the equations 1 and 4. Now here x1 is a column, the column vector of x1, the coefficients of the x1 we are going to write down here, and x2, the coefficients of the x2 we are going to write down, the coefficient of the s1 and s2 we are going to write down very similarly. Okay, here Cj values are on the top, Cj values we are going to write down. These are the cost of these variables, cost of x1, cost of x2, cost of s1 and cost of s2. Okay, now let us fill this data now. Okay, first basic variables. What are the basic variables? You need to take it. Okay, first observe the constraints, all the values I am going to write down here. Right, the coefficients x1 and x2, s1 and s2. See, look here, 1, 3, from this equation 1 and 3, 1, 1, 1, 0 and 0, 1. Okay, now these are the coefficients, coefficient matrix of the constraints. Okay, from the constraints only we are going to write down. Okay, first basic variables we have to fill in this. Okay, what are the basic variables you are going to take it here? Now that is very, very important to us. Now, as here it is forming the identity matrix. Okay, which columns are going to be form the identity matrix, that with that variables we are going to initiate the problem. Okay, here that is the reason we added the slack variables, so that this slack variable matrix is going to be form a identity matrix. If you are given two equations, now it you have to get the 2 by 2 identity matrix. Here I got the 2 by 2 identity matrix here with the slack variables, right? Okay, for that reason this is the reason I am going to take the slack variables in the basis. Okay, now this is the now I have to enter the slack variables here. See, this is s1 and s2. I am going to add it. Again, this is the cost of the basic variable. Cost of the basic variable. What is the cost of s1 in objective function? Which is 0. This value we have to write down here. 0. And very similarly, what is the cost of the slack variable of s2 in the objective function, which is also 0. Okay. As I told you, xb means the column vector on the right hand side, which is 1 and 4, right? Now, after that x1 column we are going to write down. X1 column is 1 and 3, 1 and 3, right? Okay. Then after that x2 column we are going to write down. This is the x2 column is 1 and 1. Now S1 coefficient, the coefficient of the S1 column we are going to write down 1, 0, and S2 column we are going to write down, this is 0 and 1. Right? Okay? Like this we have to fill the data. Now Cj values, the cost of x1 is 2, the cost of x2 is 3, the cost of s1 is 0 and cost of s2 is 0. This is the basic things you have to fill in the simplex table first. After this, we are going to calculate the Z values and Zj values. Okay, how to calculate the Z value? Please look into Z value. The formula of the Z is, this is Z equal to sum of, this is CBI into XBIs. Okay, this is the CB Here let me type here CB here. This is the CBI into XBI. Sum of the products you have to take it. That means how we are going to take it. This is the now this is the cost CBI. The corresponding XBI you are going to take it, these two. Multiplication of these two, 0 into 1 and 0 into 4. These, okay, these are the multiplications you have to do it. Again, you have to do the plus for the Z value. Okay, here is the, I am going to do it here, 0 into 1 plus 0 into 4, which is equal to 0 only. Now, I am going to get it, the Z value is going to be 0. Z value is going to be 0 here. Right, okay. Very similarly, we are going to calculate the ZJ values here for each and every column. Okay. The first column, ZJ values. Here, I am going to write a formula for the ZJ. ZJ equal to, how we are going to write down? Summation of CBIs into X1Is. X1 column, that is the column vectors we are going to write down. Very similar, we are going to write down. This is multiplied by this vector, and this value is going to be multiplied this. Then you are going to get addition. You are going to do it. Now the first column, this is for 0 into 1 you have to do plus 0 into 3 like this, which is also you are going to get it 0. CBI into X1Is. Okay, this is 0. Right, okay. Now the next one we are going to calculate very similar. This is 0, we will get it. The next one also we are going to get it like this only. 0 into 1 and 0 into 1. 0 into 1 is 0 and 0 into 1 is 0 again. Now we are going to get the answer here 0. Here is the 0. Right, okay? 0. Right. Very similarly, you are going to get the next values here. Next value 0 into 1 and 0 into 0. That is 0 only. We are going to get it. Here it is 0. Then again 0 into 0 and 0 into 1, which is 0. Like this, we need to compute the ZJ values here. Okay, after computing the ZJ values, now we are going to calculate CJ minus ZJ values. Okay, here CJ minus ZJ values. What is the CJ? CJ is these values. CJ are these values are CJs and these values are ZJs. Now for this we are going to calculate CJ minus ZJ for this table. Okay. Now let me calculate CJ minus ZJ for the first column X1. That is Z1 minus C1. It will become CJ minus C1 minus Z1, which is equal to 2 minus 0, which is 2 only. Now here you have to write down the 2. 2 minus 0, very similar 3 minus 0 and 3 minus 0 and 3 minus 0. Right, okay? Like this, we are going to compute all the values. Okay. Now, this will become 2 now. 2 minus 0 is 2. This will become 3 and this is 0 and this is 0. Right, okay? Now, like this, we need to compute all the values in the simplex table. Okay, after doing this, what we are going to do is, now we are going to check it whether all the CJ minus ZJ values, okay, all CJ minus ZJ values are less than or equal to 0 or not. Okay, if all CJ minus ZJ, if all minus CJ minus ZJ is less than or equal to 0, then the problem is going to be stopped there. Then stop the problem here itself. Okay. Less than or equal to 0, then you can stop the problem. But any one of CJ minus ZJ, any one of CJ minus ZJ is greater than 0, we have to continue the problem to the next iteration. Okay. Now, if CJ minus ZJ, any one of CJ minus ZJ is greater than 0, then we have to continue the problem to the next iteration. Right, okay. Now, we have to take it CJ minus ZJ values here. Whatever the CJ minus ZJ values are positive here, that values you have to write down. Out of that, maximum value you have to select. Here two values are there, 2 and 3, which are non-zero values, non-negative values. Okay, this 2 and this 2, which are the positive values. All the positive values you have to take it. Okay, until and unless all the zeros, otherwise all the negative values. If we get the Cj minus Zj, the problem is going to be end here. Okay. Out of this, you have to select the maximum one, maximum of these two values. What is the maximum here? Maximum is 3. Now I am going to select a maximum value here. This is the maximum value is 3. I have to select a maximum here. Wait a minute. Let me select this value. This is the 3. 3 is going to be. Now what is the meaning of this one is? The meaning of this is the vector x2 is going to be enter in the basis now. Okay. This x2 variable is going to be enter in the basis. Okay. Enter in the basis. Now, please remember here, whatever the basis elements are there, with that only the identity matrix formed. Okay, with S1 corresponding to S1 is 1, with S2 is corresponding to 1. This is the identity matrix. Now, in the next table, the x2 value is going to be enter in the basis. Okay, enter in the basis. If you want to enter this x2 variable in the basis, one variable has to go out from the basis. One variable has to go out from the basis. For that, we need to calculate the minimum ratio criteria. Minimum ratio criteria is like this: xb divided by whatever the xb values is there, divided by corresponding selected column element. Corresponding selected column element. Okay, let us do it. This is xb, the minimum ratio here. Minimum ratio equal to xbi divided by corresponding x2 is corresponding x2i. You are going to take it. Now, this is what we are going to do is xb divided by this value and xb divided by this value. We are going to write down here. Okay, in the minimum ratio. xb, the corresponding value is 1 in the selected column. xb, the corresponding value is 1 in the selected column. That values we are going to write down. Let us type that one here. Now, here I am going to take it. These values. This is the first one is 1 divided by 1, which is equal to 1 only. Now we are going to get the 1. Again, this is the 4 divided by 1, now which is equal to 4 only. Now, this is minimum ratio. This is the way how to calculate the minimum ratio. After calculating the minimum ratio, you have to select the minimum one here. Okay, we have to select the minimum one. In order to calculate the minimum ratio, whatever in the selected column, whatever you selected this column here, when we selected this column, in this column, is there any negative values? Negative values or zeros. For that, we are not going to calculate for that elements. In this particular column, the selected column, if there is any negative quantities, negative values or 0, then we are not going to calculate the minimum ratio. If all our negative quantities are there, then that problem is called unbounded problem. Okay, unbounded problem, we'll say that one. This is here nothing to worry here. Then all are positive values. That is the reason I calculated the minimum ratio. Okay, after calculating the minimum ratio, which one is the minimum value? You are going to calculate that one. Okay, now let us calculate. Let us take the minimum value here. The minimum value here is out of 1 and 4, you have to take the minimum value. Okay, these two values, out of these two values, you have to select. Now, this is the 1 is the minimum value I am going to select. That means what it shows that the S1 variable is going to be out from the basis. On the place of x1, S1 is going to be out from the basis. At the place of S1, x2 is going to be enter in the basis in the next table. Okay, this is the meaning of this one. Now, this is the time to identify the key element or pivot element. Now, key element or pivot element. Key element or pivot element. Pivot element. Right, okay. How to calculate the pivot element here? Now, see, here is the one column you are selected. This is the column you selected. And this is the row you selected. This is the row you selected. Where these two lines are intersecting, that element is called key element or pivot element. Key element or pivot element. Right, okay. Now, we have to select that key element or pivot element now. Now let me select the key. This is the key element. Now this is one is called now key element. Now see this one. I am highlighting the with colors here. This one is called key element now. Okay. Now in the next iteration, how to proceed with the next iteration? Okay. The next iteration is going to be proceeding like this way. Now here we are concluding that here the S1 is going to be out from the basis and X2 is going to be enter in the basis. Now in order to enter in the basis, now you have to make it X2 column as identity column. Okay, X2 column as identity column. That means you have to make it key element is 1 and above 0 and below 0 you have to make it. Here 2 by 2 the key element, this is the key element 1. If you want to make a key element 1, whatever the value is there, you have to just divide the same value the entire row, then it will become a 1. Okay, after that you have to make it in that particular column. Whatever the column you are selected, you have to make it key element is 1. Then it's remaining all values we are going to make it 0 in this particular column, right? Okay, that is our intention. Okay, let me proceed with the second table, second iteration from here. This is the end of the first table. Now we are going to entering to the second table now. This is the first table where we calculated in the previous slide. Now here we are going to calculate the second one, which is the second iteration we are going to calculate. Now just we are going to entering all the values. Okay, here S1 is going to be going out from the basis. At the place of S1, X2 is going to be enter in the basis. Next, S2 is going to be very similar in the next iteration. Okay, first we need to fill this data in the simplex table. Second iteration of the this is the second iteration. X2 and S2 is going to be entering in the base, are going to be enter in the base, are going to be in the basis. Now cost of this is cost of variable. This is cost of the X2. Cost of X2 is 3 here in the objective function. Cost of S2 is 0. Now this cost we are going to fill it again 2, 3, 0 and 0. These are the costs. Okay. Now from here onwards the new values are going to be taking place here. Okay. First we need to change the key element row in the next table. First we need to change the key element row in the next table. Now what we should do is, our intention is that we have to make it the key element 1. Okay, if you want the key element 1, this entire equation is going to be divided by 1 only. That is the reason we are doing this here. In order to make it, this is 1, I will go here 1 I get, here also 1, here also 1, here also 1. This is 0, I am going to get it. Okay, the rest of the values we are going to calculate by the formula. The formula which I written here, this is the formula we can calculate. By using this formula, we are going to calculate the rest of the values. Okay, now see new value. Okay, corresponding new value you have to calculate. What is the corresponding this value in the old table? The old table is in the corresponding value in the old table is 4. For this new value we are going to find out. The new value of 4 will become old value minus, this is the value, old value minus. Now corresponding old value of the row, corresponding old value of the row, corresponding old value of the row element value in the pivot column, corresponding old value of row element value in the pivot column. This is in the pivot column divided by pivot column into corresponding old value of the column element value in the pivot row. Okay, like this you have to calculate. Okay, it is very simple. Let me draw a diagram here. Okay, so that you can understand very easily. Now this is the old value. The corresponding old value of the row element in the pivot column. The corresponding old value of the row element in the pivot column. In this pivot column you have to select old value minus this divided by pivot column. You have to take the pivot column divided by pivot column. Again into corresponding old value of the column element in the pivot row, this row, corresponding old value in the column element in the pivot row. Like this you have to calculate. Let me write down here. This is the 4 minus 1 by 1 into 1. Right, okay, which will become 4 minus 1, which is equal to 3. Now, here is the value, we are getting 3. Here is 3, you are going to get it. Right, okay. Now, we are going to get it the another value. Here, x1 value you need to calculate. Very similar formula, we are going to take it. The formula is very simple. This is old value minus key element row value. Okay, divided by 1 into 1. Okay, like this. 3 minus 1 by 1 into 1, which is equal to 2. Here I will get 2. 2 is the value. Here, see, listen here. Here itself is going to be moving. As we know that the basis variable are going to be forming identity matrix in the simplex table. That is the reason we are going to make it 0. It is blindly. Okay, not this. This is 0. As you can take it, this is like this. This is the x2. See, listen. x2 corresponding value is going to be 1. The rest of the values are going to be 0. Why? Because with the basis elements only, the identity matrix is going to be formed. That is the reason 1, 0. And for s2 also it is going to be 1. Here also you can write down the 1, no problem in this. Okay. The basic variables, the corresponding value of x2, that is that value is going to be 1. S2, the corresponding value of S2 in that particular row is going to be 1. Why? Because this is 1, 0 and 0, 1. The identity matrix is going to be formed here. Okay. Now, that is the reason we are writing here. This is for 0 I written here. For S2 also I am going to take it here. This is 1. This is 1. It will become. Now, for the S1 column you need to calculate. What is the S1 column old value? The old value is here. 0, 0, minus 1 divided by 1 and 1. 0 minus 1 by 1 into 1, which is minus 1. I am going to get it here, minus 1 here. Minus 1. Minus 1 I got. Okay. Now, very similarly, we are going to calculate the Z value first. Okay, let us calculate the Z value. Z value is, what is the formula I told you? Z equal to CBI into XBI. Okay, CBI into XBI. 3 into 1. Into 0 into 3, summation of these things. Okay, 3 into 1 is plus 0 into 3, which will become, what is the value? Which will become 3. Now, this is the value, this Z value will become 3 now. Okay, this Z value will become 3. Now, I written the 3 here. Next, let me calculate the ZJ values here. ZJ values is very simple. This is the 3 minus 1, 3 into 1. Plus 0 into 2. Here is the value, it will become 3. This is 3. Now, this is also 3, it will become, okay. Now, 3 into 1 is 3. Now, 3 into 0 is 0. Now, we will get it like this. Now, very similarly, we are going to calculate the ZJ minus CJ minus ZJ. CJ is the 2. 2 minus CJ value is 2. Here, 2 minus 3 is minus 1. 2 minus 3 is minus 1. Here 3 minus 3 is 0. And this is 0 minus 3 is minus 3. Here minus 3. And 0 minus 0 is 0. Now here we can observe that all Cj minus Zj values. Okay. Here all Cj minus Zj values are less than or equal to 0. See, listener. Either it is 0 or less than or equal to 0. That means negative values. All values must be negative or zeros, you will get it. Okay. Then we can stop the problem here. Now this is, we will stop the problem here if we get all Cj minus Zj less than or equal to 0. Then this is the end of the problem. Now we have to select the solutions here. Okay. How we are going to select the solution? See, listen. Now the xb value, the value of bv. What is the value of BV? The x2 value is going to be 1. Like this, you are going to select the solution. x2 value is going to be 3. Now, here, see, listen here. x2 value is going to be, what is the value? x2 equal to 1. Like this. x2 equal to 1. The whatever the variables which are in the basis, that value for that values only we are going to write the solutions. Remaining rest of all the values are going to be 0. Here s2 is there, here s2 equal to 3. Here x1 is absent in the basis, which is 0, and s1 is absent in the basis, which is also 0. Now when we take the objective function, okay, now objective function, let us see the objective function once. Okay, what is the objective function? The objective function is, see, 2x1 plus 3x2, 2x1 plus 3x2. This is the objective function. Okay, now here the value of x2 equal to 1. The value of x2 is 1 and the value of x1 is 0. Right? Okay, like this. There is no x1. No need to write the s1, s2 values here, slack variables values. Okay, your max might z equal to, what is that? 2x1 plus 3x2. Now when you substitute these values, the same value you are going to get it. x1 equal to 0, 2 times 0 is 0, 3 times 1 is 3. This is the z value you wanted. Okay, max z will become now, which is 3. Okay, now this is the optimal solution for the problem. Okay, the solution is x1 equal to 0 and x2 equal to 1. This is the end of the problem.
If you like this video, please click on the like button. If you not yet subscribed our channel, please subscribe and click on the bell icon and share it. Thank you.